Anusuya, and I welcome you all to this session on one of the most upcoming and still evolving topics of the day. The latest remarkable addition to our industry is reality mesh and digital engineering. This is where the real and the virtual worlds meet to create new environments and visualizations, one where physical and digital objects coexist and interact in real time. It delivers an integrated set of geometric models, data, and documentation that builds over the life of a project to capture all knowledge related to that asset. But digital engineering is more than about creating models. It is about unlocking knowledge and insight. I have with me to talk more on this, I would like to welcome on stage Mr. Rajesh Alla, Chairman and Managing Director, IIC Technologies, Mr. John Renard, President, EMEA Region and BU Head, Utilities and Geospatial, Cyient UK, Mr. Mark FREEBURN, CEO, AM Australia, Mr. Kaushik Chakraborty, Vice President, Southeast Asia and India, Bentley Systems, Mr. ANDREAS, GERSTER, Vice President, BIM and CIM, Product Design, FARO, Germany, and Mr. JOHANNES RIEGL Jr., Chief Marketing Officer, RIEGL, Austria. It's very clear that in fields like engineering or construction or infrastructure, where we are essentially constructing or monitoring, basically dealing with the real world object, a lot depends upon the user's understanding of the spatial understanding, so that the interpretation of the virtual world is translated into the real world. Now, let's get into a bit further. My first question is to John. Tell me, John, I ask you this because from a GIS company, Cyient has been repositioning itself as an engineering company. So how do you see the shift in your customer portfolio from standard digitization to engineering workflow? And how equipped do you think is the engineering industry in adoption of these new technologies?
Okay, so that's a good question. So I suppose just to preface that, for those of you who don't know Cyient, I mean, about 2/3 of our revenue comes from predominantly mechanical and electrical engineering. So it could be designing bits of trains or planes or off-road vehicles. And I think one of the interesting things for us has been, and then 1/3 of the business, and that's where the business started 25 years ago, really came out of pure geospatial. And a lot of it was data conversion, getting the data out of the drawing offices into systems and projects that you'll be familiar with. I think there's been a lot we've been able to learn on the geospatial side of the business from our colleagues in engineering. Where it's coming together, and I guess Network Rail is a great example, we're designing, for example, with some of the big rail manufacturers, train manufacturers, sorry, the OEMs, we're actually designing the rolling stock. Well, if you're building trains and you're looking at clearances and you're looking at the design of those trains, actually having that digital railway and knowing, you know, simple things like whether the train can get into the platform or curvature on the tracks, those sort of tolerances actually become quite relevant. So we are seeing, we do a lot of work, for example, in our engineering business around signaling. So the design and the logic of signaling that both on mainline and metro systems. So again, we can see this really converging between where we come from on the geospatial side and the engineering side. So yes, I think it is changing how we operate, and I think it also is getting us involved, fundamentally it's getting us involved in larger projects.
Rajesh, you deal with a lot of engineering clients. Would you want to add to that?
I think IIC has basically been what I call a mapping and surveying company. So we were into, basically started off as a data processing company, then went downstream into data acquisition, and then upstream into data products, and then solutions. However, we have noticed that we'll have to re-engineer ourselves, or we have to reinvent ourselves. So a year ago, we have started to redefine our business models more into the domains or the engineering domains, what we talk. As an example, we have infrastructure. So in the infrastructure case, I mean, roads specifically. So we get into not just the geospatial part of it, but we get into the feasibility studies, the DPR, and then help the client get into the tendering stage, and then once the tender is awarded, do the quality control right through the life cycle of the project. So that's one way where IIC is transforming itself and its business from being a traditional mapping surveying company to getting into the engineering environment. Okay. Having said that, I think moving forward, geospatial is going to be a tool. I mean, it's going to be like physics, maths, chemistry, and it's going to be all pervasive in every walk of life. Okay. And Mark mentioned that. Mark mentioned that as a company, we cannot be, I mean, in the whole BIM environment, for example, it's not just geospatial. Geospatial is a very small component, but yet it's an important component. But the entire business life cycle involves very many different departments and skill sets. So I think we have realized that, and a year ago we have started transforming ourselves into that.
My next question is to Kaushik. You have been with Bentley for some time now. Before that, you had a long stint with Hexagon. Both companies which have very high exposure in engineering and infrastructure industries. And this is a topic that you also briefly mentioned in your presentation. How, in your opinion, are these new technologies enabling democratization of data capture process? And how do you think this is making these technologies more affordable and accessible to more and more users?
Thanks, Anusuya. Let me try. So you had a couple of points. Let me address the one about the democratization of creating or updating geospatial information. That's what you're asking. I think I mentioned this briefly as well. I think UAVs a drone or a UAV is something which is really going to help this world. Traditional photogrammetry data capture is still, the most accurate. The traditional ways of doing things: lidar, airborne lidar, terrestrial lidar. It's just in terms of that's what, especially from an Indian context, people will do it once in say 5 years or 3 years or 2 years. But the world changes, right, very fast. And what we have what we need is tools which can make it faster and more away from the hands of experts. In the traditional world of photogrammetry, you needed somebody who understood the software, understood the science, could do it all together. Some of the things we showed you, I showed in my presentation, all of that was hands-off, right? It's automated processing, creating 3D buildings, 3D city models automatically. Maybe with just 10% of the human intervention, which compared to what was there, and a lot of that comes from the evolution of computer vision and machine learning and a lot of other algorithms which have gone in. The company we acquired who made that software was just 4 years old, young 20-year PhDs who came at it from a very different perspective and not from the traditional world of photogrammetry, right? The gaming industry, many of them came from the gaming industry. So I think, so there's a lot of good tools coming out from the hardware manufacturers, to make it a lot more cost effective, lighter, more in-field, and from the software vendors, I see that we've been able to make things a lot easier. For example, a product which does all this 3D city model creation, we now run it as a cloud service, right? So if you're a user and you just want the data, somebody's flown it for you or somebody's captured it for you, you can put your photos together, you can put your point clouds together, you can upload it to a website, it processes everything and sends it back to you as a city GML. That makes it much simpler. I think John wants to add something there.
You want to add?
I just wanted to make a quick point, and not to be too contentious, but I think we're also very excited about drones in Cyient, and if you see our booth, we'll have lots of talk about drones. But I wouldn't dismiss traditional either fixed wing or rotary acquisition, because I think it's fitness for purpose. And there's still a lot in our view that drones aren't suitable for, and while they might be very cheap and you can deploy them very quickly, it's really it's sensors that are airborne, and drones fill a gap, but they're not the panacea, and they're not going to replace fixed wing and rotary.
I fully agree with you. So, I see drones, say from I'll give you an example of Singapore, right? So smart nation, Singapore, smart city. The entire city has been captured by AAM, and they have a city GML of the entire city of Singapore. Now the city wants to update, say, 2 square kilometers or 1 square kilometer every month. I don't think they'll go through the entire flying process. So just for updates and regular change detection, construction sites, mine sites. So absolutely agree with what John said. The traditional tools actually become smarter and faster and more efficient. We just have new tools which make change management and updates a lot more efficient.
Mark, you work with AM, which is essentially a solutions company. And all the trends that we're talking about, the newer as well as the old ones, it's all about collecting more and more data and different kind of data. So how do you manage such complex data structures that is integrating meshes into CAD, BIM, and then drive workflows with the existing platforms?
Standards. First thing, Kaushik mentioned Singapore. So to say, for example, to map something like Singapore from both the terrestrial mapping component, the airborne mapping component, now being incorporated with UAV sections, for example, and other forms of image data that's now been put into that. We rely heavily on standards. In this case, City GML and the OGC standards become the backbone by which we actually build and integrate data sets for people to work with. Without those standards, and I think we should all embrace that, it becomes an extremely difficult thing for us to all collaborate and work with each other. This morning's session about collaboration may be an economic base between different companies, but it also might be just on a data level between companies. In the question you asked about democratization of actual data sets and so on, this comes down to the data now being a commodity, a tradable thing, a way to actually integrate with different and work with other different environments. They may not always be as we were talking about from the geospatial world. So to make that all happen, we have to have a standard environment in which to work with. The second thing is the technology that we've actually got now. So we do have expandable, flexible, elastic, cloud-based technologies to work with. One of the things that we need to take on as part of our mission to the world is to encourage the governments of the world, who still have a closed environment in many cases, to actually contemplate the concept of using more integrated but open, as near as possible, cloud-based technologies.
Andreas, FARO has been producing very high quality sensors and enabling integration of those sensor data into advanced product environments. So what challenges do you see in adoption of these technologies in the engineering field, given that engineering is one of the least digitized industries?
Because if anybody had the easy answer to that, things wouldn't be the way they are actually today. I think one of the issues is obviously that, let's say, measurement in construction traditionally was a profession that was only attributed to very few people, named the surveyors. And the surveyors had been some real special group inside the whole construction industry. They are the ones that knew how to measure. And that was kind of a secret going back to the old Egyptians. So the guys that only could do the land surveying stuff, that had been the most powerful people. And that really didn't change so much over the centuries, I would say. So one of the challenges is definitely to democratize what I would call the art of measurement in construction, because you only can control the things that you can measure. If you can't measure it, you can't control it. And that's these kind of closed control loops that had made many other industries so successful, because it increases productivity and it minimizes failures, and it really helps to become efficient. And that is, I think, that is really the challenge. Bring everybody on a construction site in touch with measurement in a way that doesn't require a university degree in surveying. If you can accomplish that, then you have at least done half of the job. The other part of the job is definitely then to make these measurement results available at the site. That's yet another problem. If you go to a construction site today, they all work from paper. Paper, you know, it's outdated. By the time when you print the plan, it's outdated. And that's one of the problems of Berlin Airport. You know, they couldn't manage the complexity anymore because they didn't align all the changes from the different trades And that was the issue. That means after measurement, there is the challenge to bring the results to the construction site, make them available in real time. If you solve these two problems, then I would say you are done. And we are certainly contributing to that to a certain extent, but in the end it's about joining forces. You know, it doesn't help if FARO does something and somebody else does another thing. We have to collaborate. All the people from the software side, from the LiDAR side, from big data side, virtual reality guys, and then we can really make the contribution to that industry, and I think that will be the way forward.
Johannes, RIEGL has been a pioneer again in terms of sensor innovations. How do you think advancements in the fields of sensors empowered engineering professionals?
I would like to agree with Andreas first. I think for the end customer, all that matters is productivity. So I think this is true for our customers, this is true for FARO customers, other vendors and software software producers and customers as well. So we need to provide them equipment and review the existing workflow with them, empower them to make a change to the existing workflow to speed up their process. And sometimes this is a challenging task. Sometimes this takes a while to really prove technology is worth the investment, can be paid off in a short amount of time. Sometimes this needs some case studies, this needs some, reference projects. But at some point in time, if the end customer realizes the possibility to improve the workflow and to reduce the time needed to get to the desired deliverable, I think there is not so much of a barrier anymore. And you said your question was related to sensor innovation. So RIEGL has been quite an innovator in the field of LiDAR for more than 20 years. So the company exists for almost 40 years, but I would say a little more than 20 years really this 3D scanning market evolved. And we continue to evolve and push the performance levels to even further increase accuracies, speed of acquisition, ease of use as well, very much and very important, as you mentioned too. It is critical that the user in the field is not required to have a surveying degree or any special degree. The typical user at the airport or in the railway field most likely, will not have such a degree. So the systems need to be user-friendly and capable to be trained in, I would say, a couple of days. That's the maximum. If it's more, it's much too complex.
Rajesh, how do these new technologies really help? Like you talked about repositioning, how your IIC is repositioning itself for the engineering clients more and more. So where do you find they're finding value, like productivity, ROI, time management, exactly where?
How does technology help us, you're saying? Where does it?
This digital engineering and reality mesh, how is it empowering your clients? Where exactly they are finding value?
I think it's all around. I mean, it's a complete business cycle, right? However, that concept still has not come up, at least in our country yet. And we are looking at India. So the functions are still disparate. There is no one organization that provides all the services. Okay, so the sensors or the innovation that goes on is localized to each of the individual, I would say, vendors or suppliers or different parts of the complete system. So the challenge would be in terms of getting innovation from sensor integration, right? And we haven't gotten into that. IIC has still not gotten into that particular, but we foresee that that's the area where it would give an opportunity for organizations to do the complete life cycle of like an asset management or building, construction. That's it. So.
You want to add to that, Kaushik? Kaushik, you want to add to that?
I can. So there are a lot of applications we see. I think from Rajesh, I really can't say from an India perspective. What I can say is that there are a lot of organizations working in India who are doing it for overseas clients. That means the skill set, capabilities do exist in Indian engineers and Indian designers and planners and architects. The only thing which stops us is the lack of vision and foresight, I guess. And
Customer will.
It's also the willingness. So I'll give you an example of a project, right? So he mentioned Berlin as a potential failure. Let's talk about successes. And there's a project John would know very well called Crossrail, which is supposed to be the most innovative digital engineering. So Crossrail is a brand new underground train being built below the city of London. So what happened is when Crossrail was funded, before they started going to design, they cut their funding by 15 to 20%. Right? So you had to do the same project in less money. That's unique in the infrastructure world, where everybody just keeps spending and spending more and more. So Crossrail took the only way they realized they could do it is by adopting what we call BIM level 3 workflows, right? Where you create a complete digital twin of your asset and your infrastructure before you go into construction. So before Crossrail goes into construction, they have a virtual line, metro line built, and they know exactly during construction that will be updated, so that at the end of the construction phase, so remembering that what 30 to 35% of an infrastructure's cost is in design and construction, 60 to 70% of it is in maintenance, right? So the London Underground has been there for 100 years. It's cost a lot more than ever they dreamed it would to maintain it and to build it. So when Crossrail constructs, they keep on updating it. Those models will go into their operations and maintenance environments. So today what happens traditionally, say HICC for example, this was designed and built, and I can give you a guarantee it was all the data is on paper, right? But if you build this with digital twins, if you have a virtual reality model of this with all the engineering data built in, now supposing you're to change the air conditioning, it's going to be much faster to redesign it, know where the ducts are, where your HVAC systems are, and to do your maintenance or a reconstruction of the whole thing. And I think this is where the world of engineering is changing, and geospatial information and as in terms of 3D reality models are coming in to the world of engineering much faster than I think we have seen in the past.
As we have seen, reality mesh and digital engineering are fast becoming integral parts of construction and infrastructure process. As our speakers also mentioned, it's a huge part of, since a huge part of the geospatial user community are basically infrastructure users. So this is another example of geospatial going mainstream. Though the adoption is yet to catch up, we can expect a sharp intake going forward. One of the driving factors behind this is that every construction project has a decisive process, and digital engineering and reality mesh is actually enabling a transformation of reality and abstract ideas into which are basically translated into physical objects. The innovation in sensors is adding to availability of real-time data, and this trend is only set to grow exponentially. This is actually taking a BIM a step further, as the fusion of real and digital worlds provides the user with immersive virtual experience. Will this hybrid reality be the future of BIM? We will see. Thank you so much.